The universe is filled with wonders. We have discovered distant galaxies. We have unraveled the secrets of DNA. Now, we stand at the cusp of another revolution: machine learning. Imagine machines that learn from experience. Picture computers that improve their performance over time. This isn't science fiction. This is the reality of machine learning. Machine learning is a type of artificial intelligence. It allows computers to learn without explicit programming. Instead of being programmed for every task, machines can learn from data. They identify patterns. They make predictions. This ability to learn from data is transforming our world. Machine learning is already all around us. It powers our search engines. It recommends products we might like. It helps detect fraudulent transactions. As we delve deeper into the 21st century, machine learning will only become more prevalent. It will touch every aspect of our lives, from healthcare to transportation to entertainment. The future is here, and it's powered by machine learning. Join us as we explore this exciting frontier of science and technology. Let's unravel the mysteries of machine learning together and discover its profound impact on our world. At its core, machine learning is about recognizing patterns. It's about finding meaning in vast amounts of data. Think about how we learn as humans. We observe the world around us. We identify patterns. We make predictions based on those patterns. Machine learning works in a similar way. Imagine you want to teach a computer to recognize cats in pictures. You would show the computer thousands of pictures of cats. You would also show it pictures of things that are not cats. The computer would analyze these pictures. It would learn to identify the features that distinguish cats from other things. This process of learning from data is called training. During training, the computer develops a model. This model captures the patterns it has learned. Once the model is trained, it can be used to make predictions on new data. For example, if you show the trained model a new picture, it can predict whether or not the picture contains a cat. The more data the computer is trained on, the better its predictions will be. Machine learning comes in different flavors. Supervised learning uses labeled data to train models. Unsupervised learning finds patterns in unlabeled data. Reinforcement learning involves training agents to make decisions in an environment. Each type of machine learning has its strengths and is suited for different tasks. Healthcare is on the verge of a revolution, and machine learning is leading the charge. Imagine a future where diseases are diagnosed earlier and more accurately. Imagine personalized treatments tailored to your unique genetic makeup. This is the promise of machine learning in healthcare. One of the most promising applications of machine learning in healthcare is medical imaging analysis. Machine learning algorithms can be trained to analyze medical images such as X-rays, kinetic scans, and MRIs. They can detect subtle patterns that might be missed by the human eye. For example, machine learning is being used to detect cancerous tumors in mammograms. It can also help identify signs of diabetic retinopathy in retinal images. By detecting diseases at an earlier stage, machine learning can save lives and improve patient outcomes. Machine learning is also transforming drug discovery and development. Developing new drugs is a time-consuming and expensive process. Machine learning can accelerate this process by identifying promising drug candidates and predicting their effectiveness. By analyzing vast databases of genetic information, machine learning can also help develop personalized treatments. This means that treatments can be tailored to an individual's unique genetic makeup, increasing their effectiveness and reducing side effects. The financial industry thrives on data. Every transaction, every market fluctuation, every customer interaction generates a wealth of information. Machine learning is uniquely positioned to unlock the insights hidden within this sea of data. One of the most well-established applications of machine learning in finance is fraud detection. Machine learning algorithms can analyze transactions in real time. They can identify patterns that indicate fraudulent activity. This helps banks and financial institutions protect their customers from financial losses. Machine learning is also being used to improve risk assessment and credit scoring. Traditional credit scoring methods rely on a limited number of variables. Machine learning algorithms can analyze a wider range of data points. This provides a more comprehensive and accurate assessment of an individual's creditworthiness. Algorithmic trading is another area where machine learning is making its mark. Machine learning algorithms can analyze market data and identify trading opportunities. They can execute trades at lightning speed, much faster than any human trader. Customer service is also being enhanced by machine learning. Chatbots powered by machine learning can provide instant answers to customer queries. They can also personalize interactions and offer tailored recommendations. Section 5. Driving into the future, machine learning and autonomous vehicles. The automotive industry is undergoing a seismic shift. Self-driving cars, once the stuff of science fiction, are rapidly becoming a reality. And at the heart of this revolution lies machine learning. Autonomous vehicles rely on a complex interplay of sensors, algorithms, and machine learning models. These vehicles must perceive their surroundings, make decisions, and navigate roads safely. Machine learning enables them to do all of this and more. Computer vision, a field of machine learning, allows autonomous vehicles to see the world around them. Cameras and sensors capture data about the vehicle's surroundings. Machine learning algorithms process this data to identify objects such as cars, pedestrians, and traffic signals. Machine learning also plays a crucial role in path planning and decision-making. Autonomous vehicles must be able to plan a safe and efficient route to their destination. They must also make split-second decisions to avoid obstacles and respond to changing road conditions. The development of autonomous vehicles is a complex and challenging endeavor. However, the potential benefits are enormous. Self-driving cars have the potential to reduce accidents, improve traffic flow, and increase accessibility for people who are unable to drive themselves. Section 6. The proof is in the algorithms, real-world success stories. Machine learning is transforming industries and improving lives. Google Translate breaks language barriers with deep learning. Netflix personalizes recommendations, revolutionizing entertainment. Fraud detection systems save billions by preventing fraud. Machine learning improves medical diagnoses, saving lives. These examples show machine learning's transformative power. Section 7. Machine learning by the numbers, statistics, and advancements. The field of machine learning is evolving at an astonishing pace. Breakthroughs are happening all the time. The global machine learning market is expected to reach $117 billion by 2027. This growth shows the increasing demand for machine learning solutions. Deep learning has been particularly transformative, achieving state-of-the-art results in image recognition, natural language processing, and speech synthesis. Machine learning thrives on data. Powerful computing resources have driven advancements. Section 8. The ethical considerations, navigating the impact of machine learning. As with any transformative technology, machine learning comes with its own set of ethical considerations. It's crucial that we develop and deploy machine learning responsibly, ensuring that it benefits society as a whole. One of the primary concerns is the potential for bias in machine learning algorithms. Machine learning algorithms are only as good as the data they are trained on. If the training data is biased, the resulting algorithms will also be biased. For example, if a facial recognition algorithm is trained on a dataset that predominantly features faces of a particular race, it may perform poorly on faces of other races. This can lead to unfair and discriminatory outcomes. Another concern is the impact of machine learning on employment. As machine learning automates tasks previously performed by humans, there is a risk of job displacement. It's important to consider the societal implications of this shift and explore ways to mitigate potential negative consequences. Transparency and accountability are also paramount in the development and deployment of machine learning systems. It's crucial that we understand how machine learning algorithms make decisions, and that we have mechanisms in place to hold them accountable for their actions. Addressing these ethical considerations is essential to ensure that machine learning is used for good and that its benefits are shared by all. Section 9. A future shaped by intelligence, the transformative power of machine learning. We stand at the precipice of a new era, an era shaped by the transformative power of machine learning. The possibilities are as vast as the cosmos itself, filled with both promise and challenges. Machine learning has the potential to solve some of the world's most pressing problems. It can help us combat climate change, cure diseases, and explore the universe in ways we never thought possible. It can enhance our creativity, improve our decision-making, and connect us in more meaningful ways. However, the future is not predetermined. It's up to us to shape the trajectory of machine learning and ensure that it's used for the betterment of humanity. We must proceed with caution, guided by ethical principles and a deep understanding of the potential consequences of our actions. The journey ahead will be filled with both triumphs and setbacks. But by embracing the power of machine learning while remaining mindful of its limitations, we can create a future where intelligence empowers us all.